So hello everyone, and thank you for joining today's session on an introduction to people counting with LoRaWAN technology. My name is Céline Deltra. I'm communication specialist at Terabee. Just so you know, we are recording today's session so that we can make it available to you afterwards. I'm joined today by my colleagues Baptiste Potier,
Hello.
product manager for smart buildings, and Frederic Tabus, marketing intelligence manager. Hello guys. Fred and Baptiste are going to be giving the bulk of today's presentation. So if we have a look at the agenda, we will have first a brief introduction on Terabee. Then we will cover LoRaWAN ecosystem in 2022, as well as the opportunities that the technology brings to smart buildings. And we'll finalize with the review and guidelines of solutions with LoRaWAN. At the end, we will have a Q&A session. To take if you can mute yourself, please. Thank you. There is a Q&A tab down at the bottom of your screen to type the questions, so feel free to use it, and we'll get to those at the end of the presentation. So without further ado, I'd like to hand over to Fred for the introduction to Terabee. Fred, over to you.
Thanks, Céline. So good afternoon. So let me introduce you to our company. So who is Terabee? Well, we are a French sensor and sensing solutions company that was founded in 2012. So we work very closely with CERN, and we have developed over 20 hardware and software solutions in the past 10 years, and we won multiple awards. In terms of our core competencies, we specialize in LED rangefinders and 3D time-of-flight cameras, and we have also developed solutions in smart buildings. You can find more about these products and our company on our website. There are also the technical specifications, use cases, and information about partners we work with. So feel free to check that out at the end of the presentation. To open this webinar, let's talk first about the LoRa ecosystem, where it stands in the IoT landscape and its dynamics. So you are going to hear about the terms LoRa and LoRaWAN during this session. While both words look the same, they have different meanings. LoRa is a modulation technique for a specific wireless spectrum, while LoRaWAN is an open protocol that enables IoT devices to use LoRa for communication. Since the release of the first LoRaWAN specification 7 years ago, the LoRa ecosystem has seen spectacular growth for the following reasons. This low-power, low-cost protocol is an excellent fit for sustainable development projects. The LoRa network is now global and uses an unlicensed spectrum. As a result, 500 million LoRaWAN devices will be deployed in the world by 2025. And as an example, the share of LoRa in US companies' IoT deployments will grow from 15 to 30% in the next 2 years. So now I hand over to Baptiste.
Thank you, Fred. So talking about LoRa, it's also about its architecture and the different elements that compose this architecture. So let's start with the beginning. The end nodes are also called end devices. These are the sensors or actuators sending LoRa wireless messages to the gateways or receiving messages back from these gateways. The gateways simply forward them to the LoRaWAN network server, and each gateway is registered to a LoRaWAN network server. So you understand it, the network server is the core of the LoRa architecture. It enables the connectivity, the management, and the monitoring of devices, gateways, and the end user applications. Its main objective is to ensure the security, the scalability, and the reliability of data routing throughout the network. And at the end of this chain, we have the application server, the piece of software running on the server that is responsible for the application data process received from end devices, such as charts and graphics, for example. It also generates all the application layer downlink messages and send them to the connected end devices through the network server. So now that we have discovered the LoRaWAN architecture, let's see the opportunities that this technology brings to a smart building environment. So LoRaWAN technology offers compelling features and benefits for a wide variety of sustainable IoT smart building applications. And here on these slides, we will list some of them. First, it has an excellent indoor coverage. The ability for signals to penetrate deep within smart building is a prerequisite for indoor connectivity, especially in large multi-floor buildings or with underground spaces such as parking. It is quite easy to install. Only handle it once principle. LoRaWAN devices are simple to install and can be easily installed by non-specialized workers. This makes them particularly suited to the retrofit markets. LoRaWAN also enables organizations to install a completely private network, requiring no contract with a network operator or coordination with corporate infrastructure. The smart building applications require connectivity at relatively low data rates with no requirement for ultra-low latency. So cellular is not needed. It's cheaper and simpler to install. Finally, LoRaWAN established a worldwide ecosystem of application, but also devices for smart building operator to success. Now that we have seen how LoRa technology can be powerful in smart building environment, let's dive into more common application. We can divide the LoRa smart building application into two main parts. On one side, we have the technical management applications that are directly related to the building management system, which can include HVAC maintenance and optimizations to avoid HVAC failures, optimize HVAC controls from people flow, electronic system maintenance, or utilities, submetering and energy usage, such as water consumption and leak detection or gas. On the other side, there are workspace management applications that are decoupled and overlying the IT and BMS infrastructure, where we can find desk monitoring for flex working environments or remote working policies since COVID, building and room occupancy, meeting rooms booking, space usage, access control, or energy usage optimization, people flow measurements, for example, for predictive cleaning toilets, restaurants or cafeteria flow organizations. Environment control of air quality, so control for user employee comfort. All these technologies simply enables property managers to track building systems, maximize efficiency, and maintain a comfortable and productive work environment regardless of technical experience. Now, let's focus on the technical management application and its integration with the BMS architecture. So here on this slide, we have an example of the integration of a LoRa end nodes device. So here in this case, it's a Terabee People Counting LXL LoRa with a smart building LoRa gateway. The gateway shown here is from WattSense. So this gateway is a smart building gateway that simplifies the connection into BMS system, as it already has some LoRa devices listed and compatible with their gateway, including our devices. They have either web or local solution to easily provision and manage devices on the network. So the end nodes will send data to the gateway via LoRaWAN protocol. The gateway here acts as network server and application server. So the gateway receives and decrypts the data. On top of it, the customer will build a custom application on the gateway to send the signal understable by the BMS system with the set points it needs to execute. The output of the gateway, the signal transmitted, is then in Modbus TCP or BACnet IP to BMS system. So these are the most common systems to talk with. Now that we have seen how to integrate a device into a BMS architecture, let's review the different types of LoRa sensor that can be used to count people and measure building occupancy.
Thanks, Baptiste. So the most common usage of these LoRa sensors is to help understand the use of the different building spaces, primarily for space and cost optimization, while preserving the building occupants experience. These sensors can be grouped into 4 families. First, desktop occupancy sensors. Placed under each desk, they tell you if a person sits at its desk. Relatively inexpensive, they are battery powered for the majority of them. Then occupancy sensors. Actually, some desktop occupancy sensors can also be used as occupancy sensors, ceiling mounted. And they can detect people or even count people present within a small to medium area below the sensor. A bit more expensive, they often use batteries. Then comfort sensors are also called indoor air quality sensors. They report air quality metrics such as CO2 or TVOC that can reflect a level of human activity. Their price varies depending on the sensor modules inside, and the entry-level sensors run on batteries. And last but not least, the people counters. They measure bidirectional people traffic, and this data can be turned into occupancy metrics for a whole building of some of its parts. More complex and more expensive, these sensors require mains power to deliver accurate data reactively. Now, let's review the specific sensor features related to each sensor family that you need to be aware of to make informed decisions for optimal utilization of these sensors into your smart building project. Desktop occupancy sensors. Equipping each desk with a sensor can quickly turn into a massive sensor deployment with an heavy related device management. Occupancy sensors. So these sensors may require some calibration, and they are not adapted to large rooms or spaces. Plus, RGB-based sensors raise GDPR or privacy concerns. For comfort sensors, there is a latency to convert air quality metrics into a level of human activity, thus introducing a delay in resulting data and for remedial action. And finally, with people counters, their data may require aggregation with data from other people counters to turn this data into occupancy metrics. And just like RGB-based sensors, the stereo vision systems raise GDPR/privacy concerns. Let's pursue with the integration of the LoRa sensors into building management systems, like the one mentioned by Baptiste, the HVAC systems for ventilation or heating. For this specific use case, the LoRa sensors are not only meant to report data for analytics or even alerts, they trigger actuators in the management system of the building, which makes these sensors critical to the building operations. This is why you can buy yourself peace of mind with power-wired devices. Then you will let the sensor communicate at the highest frequency and continuously operate without running out of power. A few words about battery-powered sensors in smart buildings. I mentioned earlier that 500 million LoRa devices will be in the field by 2025. And this is not without consequences. As you can read, about 78 million batteries powering IoT devices will be dumped globally every day by 2025 if nothing is done to improve their lifespan. So while we hope our scientists to find solutions to improve the battery's lifespan, 2025 is tomorrow. So what about finding another solution now? Reducing the number of waste batteries by limiting the usage of battery-powered devices. We are talking today about LoRa implementation in smart buildings. And within buildings, sources of mains power are within reach everywhere to power wired devices. So this is an achievable objective. And while pulling a power wire is more expensive than installing a battery-operated device, keep in mind that organizing a battery replacement campaign for hundreds of devices, maybe in 2 or 3 years, it's also something costly and complex to execute. So, following the considerations of the previous slides, our simple piece of advice is this one. Beyond the product technical specifications and brochures, look at the big picture and ask yourself questions as the following. In my flex office, what do I need to measure? The occupancy of each desk or specific desk or the overall workspace availability? And then you can read other questions on this slide. Actually, based on our 10 years of experience acquired in mobile robotics, Terabee follows the lean sensing approach. This is that once you have determined your objective, what you want to achieve, you minimize your points of measure. And in the current case, it means to reduce the number of devices to install. I now hand over to Baptiste.
So let's take as an example a use case where this kind of question have been put. Here, our customer, a large property owner company with multiple buildings of several floors each, is rented some part of its floors to external companies. Their goal is to reduce and optimize their real estate expenses by making the most of space available. Their customer want also to know the real space use by checking meeting rooms and workspace occupancy in order to save costs on one side, but also ensure comfortable and productive environments. Challenges: the company owns some building with Haussmannian-style architecture. It is difficult to make building renovation work in this environment, or it can be very costly. They have very large open space and workspace to cover big meeting rooms. They have also GDPR concerns from their employee union and also the employee from their customer. No RGB camera. The solution needs to ensure that there is no way for devices to be able to recognize an individual person or people. One strong point was also to avoid dealing with the in-house IT networks to not add too many delays and to remove the need of creation of a separate networks. Again, it is a challenge of existing buildings where it is difficult to pull Ethernet cables to every location or it will cost too much. The solution chosen should have the capabilities to be integrated in a HVAC BMS system to pilot HVAC thanks to people counting data in order to reduce energy consumption and costs. In this case, our people counting AXL LoRa device was fulfilling the different requirements. First, because of the LoRaWAN technology, as it has wider, stronger, and cost-effective coverage for large spaces monitoring compared to other wireless technology. It has secure and decoupled people counting data transmission. No IT networking issue anymore related to data security. It is also a reactive system, down to the minute push. Of course, this is depending on the network layout. For HVAC integration to be capable to react fast for better energy savings. And secondly, because the people counting AXL LoRa fulfilled all use cases and requirements. So remember, it was people flow analysis, building floor occupancy, when aggregating of multiple devices data together, and finally, workspace monitoring. The other point was it only needed few devices above passageways to cover building floors and get all insight needed. It is GDPR by design, so it preserves anonymity while counting people, guaranteed by top technology. So here, for example, on the top left corner of the slide, you can see the 3D camera view of our devices. It is impossible to recognize someone. It has a typical accuracy of 98% while counting multiple people at the same time. So this accuracy is guaranteed even when counting group of people or people crossing. And it has uplink and downlink commands for remote device management. This part also is limiting the need of people going on site to solve issues, which can impact the return of investment. So here there is the Terabee ecosystem for people counting XL LoRa. So we have the gateways, the network servers, the application servers, and the marketplace and distributors partners. And there are more coming soon. For more information about our product, you can go on terabee.com and on our people counting product page.
Yeah, thank you, Fred and Baptiste, for the presentation. We have time for questions. So as a reminder, there is a Q&A tab at the bottom of your screen on the right side. So feel free to put them in, and I will read them and we will answer. Let me check if there is a question. I have one question from Pascal, who is asking, how is your people counting powered?
So our people counting device is powered via micro USB, so 5 volts, 2.5 amp. So it's not a battery device, as we mentioned the comparison between battery and wired device. So yes, PCI XL LoRa is wired device via micro USB for the power.
There is also a question from Thierry, who is asking, what is the sensor resolution?
So the sensor resolution is 80 by 60 pixels, so 4,800 pixels.
Okay, I hope that answers the question, I guess, yes. And another question from Jose, who is asking, how can I integrate your counter in my LoRa infrastructure?
So if it is a traditional LoRa infrastructure, you have the gateways, and you have, I didn't mention about the device UID and the application key. So this is classical LoRa configuration parameters. There is a web configuration GUI on the people counting XL LoRa device. So the device UID and the application key are available there, and you just need to enter them on your gateway and to create the communication between the devices and the gateway.
All right, thank you. One last question from Clément, who's asking, how do you manage the monitoring of the very wide passageways?
So for very wide passageways, we can merge sensors together. So one more information about this is that for wide passages, for merging devices, we can obviously not communicate at a fast rate enough in LoRa. So in this solution, we need to link the devices together through an Ethernet switch. So the devices needs to be locally, so it doesn't need to be on the network, IT network of the company, but you need to create a dedicated, separated Ethernet connection so that the device together can communicate. and it's only the coordinator or master device that will send the data to the endpoint systems.
Okay, I guess it answers the question. Jane is asking, do you supply support services for people counting?
Frederic.
Sure. So the devices are coming with I would say ship with warranty of 12 months, and you can purchase additional warranty for +1 or +2 years.
Okay, excellent. Let me check. Clément is also asking another question. Does your people counting M works in LoRa?
No, so we only put in front our PCLX on LoRa today because it's our only people counting devices working in LoRa. The PCM is working today in Wi-Fi, Ethernet, or PoE mode, so not LoRa yet, but we plan to do it for the future.
Jen has a follow-up question.
Yes.
We wanted to have more info on the people counting services. If we can develop a little bit on the offer. What is behind the offer?
So behind the offer, so the people counting services for the LoRa are primarily, let's say, hardware support. So basically, as a customer, you would contact Terabee. We would perform a troubleshooting with you, and if it happens, so we would help you possibly with implementation of the product, or at least would give you the documentation. And we would diagnose if the device is faulty, and if it's the case, we would proceed with the replacement of the device. On top of this, we may help you with additional what we call professional services like consulting. So we may also help you with I would say the architecture of the how to deploy I would say our devices in your projects. So this is another array of paid services we can provide.
So you can give us a floor plan. We will help you to place the device, to define the occupancy zone you want to monitor. We will also, depending if you have a challenging environment, we can help you to tell you where to place the device, how to configure it. We can also help in the device configuration remotely if needed. So yes, this is all the services that we can provide. And of course, the device management troubleshooting, as Frederic mentioned.
Okay, great. I think there is no further question, and we are anywhere reaching the end of the time. So if you have any question, feel free to reach out to the Terabee team. We will be sending a follow-up email shortly with all the contact details, and of course, you can also find our contact on the website. So thank you again, Fred and Baptiste, for the presentation, and
Thank you too.
Thank you,
Thanks for following us.
Yes.
And have a good afternoon, everyone. Bye-bye.
Bye-bye.